Welcome back to Math with Mr. P. Today we're doing 7th grade math, chapter 5, lesson 2, and we're dealing with sequences. Sequences are going to be pretty quick and easy. A sequence is an ordered list of numbers. Each number in a sequence is called a term. In an arithmetic sequence, each term is found by adding the same number to the previous term. So, an example here. 1, 3, 5, 7, 9, 11, 13. This is an arithmetic sequence. Every number goes up by plus 2. We are adding 2 to each one. This makes an arithmetic sequence. If we look over here at this sequence here, so the real world link here is the number of students who went on each horseback riding trip is shown. Do the numbers represent terms of an arithmetic sequence? Explain. So this is a sequence. For the first trip, 15 kids went. The second trip, 16 kids went. Third trip, 18 kids went. Fourth trip, 21. Fifth trip, 25. If we look at this, it goes from 15 to 16 to 18, 21, 25. It is not going to be an arithmetic sequence because from 15 to 16, only one difference. From 16 to 18, it was a 2 difference. From 18 to 21, 3. And then from 21 to 24, 4. This is a pattern, but it is not an arithmetic sequence. Again, an arithmetic sequence is each term is found by adding the same number to the previous term. In order to get to 15 to 16, we add 1. From 16 to 18, if I add 1, it's not going to work. 16 would go to 17. Therefore, this is not an arithmetic sequence. This is just known as a regular sequence. In an arithmetic sequence, the terms can be whole numbers, fractions, or decimals. Again, every number in a sequence here is known as a term. So, for example, from 8 to 13 to 18 to 23, each one is going up by 5. Therefore, this is an arithmetic sequence. If I were to find the next 5 terms, I would just add 5 to each term. To find out what comes after 23, I'm going to add 5 to it, as highlighted here, which is 28. In order to find the term after 28, I would add 5 to it and get 33. And then to find the term after 33, I would add 5 more and I would get to 38. Therefore, the next 3 terms are 28, 33, and 38. Here's another example of an arithmetic sequence. 0.4 to 0.6 was being a change of 0.2. Then another change of 0.2 to get to 0.8. And then to get to 1.0, another one. The next 3 terms, we would just add 0.2 to each one. We'd get 1.2, 1.4, and 1.6. Describe the relationship between the terms in each arithmetic sequence, then write the next 3 terms in the sequence. So in this one, it's telling us that these are all arithmetic sequences. They're all going up by the same amount. They want us to explain the relationship. A is going to be a pretty easy one because if you have 0 as a term and it goes up to the next number, you already know what we're changing. So from 0 to 13, it had to go 13 plus. The next term is 26, and if you add 13 to 13, it does check off. The next one is 39, so it did check off as well with 13 more. They want us to find out what the next 3 terms in the sequence is. So we're going to do this on our digital whiteboard. So again, our arithmetic sequence is going up by 13. The last term was 39. So I need to figure out the next 3 terms. I'm going to add 13 to each thing, or each term. 9 plus 3 is 12. Carry the 1. 1, 3, 1 will be 52. So the next term in the sequence is 52. 52 plus 13, 565. And then the next term in the sequence should be 78. So to answer this question, I'd have to write out the next three terms, which are right here. And I'd have to show that each term is going up by 13. Or I just write plus 13, or I write a sentence out saying each term is increasing by 13. Write an algebraic expression. In a sequence, each term has a specific position within the sequence. Consider the sequence 2, 4, 6, 8. So 2 is the first position, 4 second, 6 third, 8 fourth position. Notice as the positions increase by 1, the value of them increases by 2. So our first position is 2, second was 4, third was 6, fourth is 8. They want us to write an algebraic expression to represent the relationship between any term and the sequence. Therefore, let's see. In this case, n represents the position of the sequence and the value of each term is 2. So for position 1, we'd plug in 1 for n. 2 times 1 is 2. That's the value. For position 2, we plug in 2 for n. 2 times 2 is 4, and that's the value of the term. Position 3, same thing. 2 times 3 is 6, and then position 4, 2 times 4 is 8. Therefore, we have turned our sequence into an algebraic expression. Each value of the term is twice the number of the position. So for our fifth term, we would plug in 5 here. 2 times 5 would be, and our term value would be 10, and so on. All right, so we're looking at this example here. If the pattern continues, what algebraic expression can be used to find the number of circles used in any figure? How many circles will be in the fifth figure? So this is where we're going to write our table. Figure 1 had 3 circles. And we've kind of frozen, but here we go. So position 1 had 3. Position 2 and position 3. So we're writing out our table. Position 2, or figure 2, 1, 2, 3, 4, 5, 6, has 6. And figure 3 should have 9, but we're going to count 1, 2, 3, 4, 5, 6, 7, 8, 9. Therefore, our value is n times 3. Whatever this value is, we multiply it by 3 to get our value. So in our first position, 1 times 3 was 3. 2 times 3 was 6. 3 times 3 is 9. How many circles will be in the 50th figure? So we don't have to count them all up. We just do 50th figure and plug it in. So again, it's 3 times n is our algebraic expression. I plug in 50 for n. 3 times 50 will be 150. So 150 circles will be in our 50th figure. And that's all for sequences. Again, if you have any questions, comments, concerns, if you're in my class, you know how to reach me on Teams. If you're not, leave a comment down below and I will answer you as soon as I can. This has been Mr. P. I'll catch you guys on the next one.